All right, good afternoon, good evening, ladies and gentlemen. Welcome to a series of online lessons. For those that we are learning with, we already started looking at determinants and how to use row operations to evaluate determinants. And one of the questions, or among the questions that you're going to encounter as you're using row operations to find determinants, is this question here, or among others, this question here where you're asked to simplify without expanding. So you're going to use row operations to evaluate these determinants. And basically in this lesson, we will look at this question here. So that's the question that we're going to solve. So let me just pull it up on my main screen. So the question is pretty straightforward. So it asks us to find the general value of theta which satisfies this determinant. So when you see these straight brackets, they are simply the determinant of whatever is inside here. So we have to find the determinant of this. Then after doing that, we will solve for theta. Then we'll see how we go from there. All right, so as you can see, we have 1 plus sine squared theta, cos squared theta, 4 sine 2 theta, sine squared theta, 1 plus cos squared theta, 4 sine 2 theta, 1 plus 4 sine 2 theta, cos squared theta, and we have sine squared theta. Now, what we want to do is we want to have either this point or that point have zeros. So remember this part and that part to be zeros, or we can choose that part and that part to be zero, or we can choose any of the parts to be zeros. Then we move on from there. So now let's try to make zeros here. How can we make zeros here? So, but for starters, we know that when we add sine theta and cos theta, we know that it gives us 1. Okay, so let's try to do that. So we can start with column operations. Maybe we say column 1 will be column 1 plus column 2. Remember, we can use both column and row operations. So column 1 will be column 1 plus column 2. So we are changing column 1. So we're saying 1 plus sine squared theta plus cos squared theta will be 1 plus 1, because sine squared theta plus cos squared theta is equals to 1. So this and that will add to 1. Then same applies here. Sine squared theta 1 plus cos squared theta. When the sine squared and the cos squared add, it will be 1. So it will be 1 plus 1. So let me just write the final cut, which is 2. So this will be 2. So that I avoid writing over and over again. So that will be 2. Same applies here. This plus that will be 1. Then plus that will be 2 again. Then this and that, it will be 1. Then everything remains unchanged. That is cos squared theta, 1 plus cos squared theta. Then we have cos squared theta. Then we have 4 sine 2 theta, 4 sine 2 theta, and 1 plus 4 sine 2 theta. All right, so we have that. So now we can move on. So we can do our business where we create a 0 here and here. We can create a 0 anywhere. So we'll use row operations. So we can say row 1 let's create zeros here. So maybe let's swap row 1 and row 3. So swapping row 1 and row 3, we are going to have 1 cos squared theta, 1 plus 4 sine 2 theta. Then we have down here we are going to have 2 1 plus cos squared theta, 4 sine 2 theta. Then row will be 2 cos squared theta, then 4 sine 2 theta. All right, so that will be that. Then now we can now make zeros here. So we'll say row 1 or row 2 will apply to row operations. Row 2 will be equals to row 2 minus row 3. So row 1 remains the same, 1 cos squared theta, 1 plus 4 sine 2 theta. Then when we say row 2 minus row 3, this minus this will be 0. Then this minus that, or this minus that, that will be 1. This minus that, that will be 0. Okay. Then we can also apply the row operation. Row 3 changes to row 3 minus 2 row 1. Okay, and remember all those theories that we learned. So we cannot use row 2 in row 3 because we are from transforming row 2. So now this times my row 3, which is 2, and this will give us 0. So row 3, which is cos squared minus 2 times that will be negative cos squared theta. Row 3, which is this, minus that, so that is 4 sine 2 theta minus 2 minus 8 sine 2 theta. So we see that it will simplify to negative 2 minus 4 sine 2 theta. Okay, so that simplifies to that. Okay, and remember this is equal to 0, but we'll do the equal part later. All right, so we have that. Then now from here, we simply do the cofactor part. So we see that we just pick the one, the cofactor is 0 because they'll multiply in 0. So we just pick whatever number that is there. So that is a 1 times what is inside here, which is 1 negative cos squared theta, 0, then negative 2 negative 4 sine 2 theta. And remember, this is equal to 0 according to the question. Let me see if I can see this is equal to 0 according to the question. So now here, we see that we can cross multiply, finding the determinant. So this times that will be negative 2 negative 4 sine 2 theta. Then this times that will be 0. So this will just be equal to, so this times that is 0, then we have equal to 0. Okay, so now we can transpose. So we have negative 4 sine 2 theta equals to 2. Then sine 2 theta will be equal to negative 2 over 4, which just simplifies as sine 2 theta equal to negative 1 over 2. All right, so now from here, this is where we now find the general value of theta. Okay, so how are we going to find the general value of theta? So we need to find a few values of theta, then we see if there is a pattern, then we generalize the formula, right? So for this one, we'll let k equal to 2 theta, so that we put in here, so that sine k will be equals to negative half, and k will be equals to sine inverse of negative half. Okay, so now sine inverse of negative half. All right, so when punching that on your calculator, make sure that your calculator is in degrees. So sine inverse of negative half will give us k equals to negative 30 degrees. Sorry, not 30. Negative 30 degrees. Then k is equals to 2 theta. So k is equals to 2 theta, meaning that our first value of theta will be equals to negative 30 over 2, which is negative 15 degrees. Okay, converting this to a positive value, or finding the positive value of this, we'll try to locate negative 15 degrees. So how you locate negative 15, you draw a simple x or y plane, and we know that going the negative route, it will be somewhere there. So negative 15 will mostly be there, that is negative 15 degrees. Then the positive counterpart will be there. Okay, so that will be from here all the way there. So this is also 15 degrees. So that is 180 minus 15. That is 165. So this is 165. So negative 15 degrees is also equal to 165 degrees. So this is the first value of theta. Okay, we can convert this to polar form, or I mean to radians, by saying 180 degrees is equals to pi, 165 is equals to x. X will be equals to 165 pi over 180, which when these are simplified, we have 11 over 12, so 11 pi over 12. So 165 degrees is also equal to 11 pi over 12. Okay, so that is the first value of theta. Now let's find the second value of theta. So we should also find it in radians. Find the second value of theta, we can use this very line. So what we should just do is we extend from 0 degrees all the way to the other part of the line. So we'll just say 360 minus 15 degrees. That is 345. 345. So the second value of theta is 345. Then again, converting this to radians using the same procedure. So that will be 23 pi over 12. So now from here we can, all right, so that is the second value of theta, which is 23 pi over 12. Now notice if we continue going round like that, maybe we find the third term, we'll have a sequence of numbers. Now to put it simply, The first term of this sequence will be 11 pi over 12. The second term of the sequence will be 23 pi over 12, and it will go on and on. And the difference, of course, will be pi. Okay, because yeah, so that is when you say 23 over 12 pi minus 11 pi over 12, the difference will be pi. Okay, so this will form an arithmetic sequence because when we continue rounding between these points, we'll continue having an arithmetic sequence. So the common difference d will be equals to a pi. Now we can find the nth term, which is the general theta. So t theta will be equals to the first term plus the nth term minus 1 multiplied by the common difference. So we'll just say theta n will be equals to the first term, which is 11 pi over 12 plus n minus 1. Then the common difference is pi. Then if we simplify this, we're going to have 11 pi over 12 minus pi plus n pi, which will simplify to n pi. And when we subtract here, it will be negative pi over 12. So that is the general value of theta. Okay, so that is actually, this has two answers, but you can just settle with this one because there's another angle that is 210 degrees. It is also right there, so 210 degrees. So if you do the same, you will find another series. So but we can just settle with that general value of theta there. So that's basically it. So that is how you are supposed to work out the problem. Maybe just a run through. So find the general value of theta, which satisfies this equation. So we first started by simplifying until we found sine 2 theta equals to that. We found the values of theta in radians. Then we created a sequence. Then from there, we found the general value of the sequence. So that's basically it. Have a good evening.